Okay, so quick video for the review for quiz 2. Okay, so we've got it in standard form. We're asked to write each function in all three forms, identify the key features, and graph the functions. So we've got standard form. We want to get it into vertex form because that's the easiest one to graph from. So it becomes, this is where A is 2, B is negative 20, and C is 48. So that's going to be positive 20 over 2 times 2. That ends up giving us 5. So that's the x value of the vertex. Substitute it back in to the original function to get the y value. So that's going to be 25 times 2 is 50, minus 100 plus 48, negative 50 plus 48 is negative 2. So then your vertex is going to be 5 and negative 2. We can take this information over here. So f of x equals the a value follows through. So it's 2 times x minus 5 squared minus 2. Now let's plot this first and see if we can help get factored form without having to do too much work on that. So we plot it at 5 and negative 2. We've got a stretch of 2, so that means we go over 1 and up 2, because remember we go over 1 up 1, so 1 squared is 1 times 2. We go over 2, square that, that's 4 times 2 is 8, so 2, 4, 6, 8 on both sides. And since it goes nicely through the vertex, through the x-intercepts, we can use that to help us get factored or intercept form. So when we write factored or intercept form, change color. We have 2 at the beginning, and remember it's x minus m, x minus n, so it's going to be x minus 4, x minus 6, because of our x-intercepts being 4, 0, and 6, 0. Domain negative 0 to, negative infinity to infinity. Range is going to be from the lowest value, which is negative 2, to the highest value, which is 0. Y-intercept, when we put 0 in, we can look at it here, 0, 0, and 48. Axis symmetry, x equals 5. Roots are solutions, so that would be when we write the curly brackets, when we write 4 and 6. And types of 0, we have 2 real roots. Remember that roots and zeros and solutions are all mean the same thing, along with the x-intercepts. Unless there is no x-intercepts, then they're imaginary, but they're still solutions. Okay, so vertex form. Getting into standard form, we have to do a bit of math here, multiplying it out. So that's going to be x plus 3 times x plus 3, so that's x squared plus 6x plus 9. Remember, we're doing x plus 3 times x plus 3. And I want to distribute here, so I'm going to go down here and do a little bit of work so you can see that. We've got 3x squared plus 18x plus 27 plus 2. That means we get 3x squared plus 18x plus 29. Vertex is negative 3, positive 2. Again, let's graph this and see if we can give us information to help with factored form. So negative 3, positive 2 is here. This is a positive a value, so it's going to go up. So over 1, up 3, 1, 2, 3. And then it would be over 2, 2 squared is 4, then we'd actually be up 12. We can't fit that in, so we're just going to graph it right here. It's pointing up the way, so it's never going to cross this x-axis. So that means there's no factor form because it's not crossing the x-axis, therefore there's no x-intercepts. Domain negative infinity to positive infinity. Range is lowest, which is positive 2 to infinity. Axis of symmetry is x equals negative 3. Y-intercept 0, 0, 29. X-intercept none, that means there's no solutions or roots. And then type, there are no real roots or no real solutions. There are solutions, but they're not real. Okay, next page. So this is where we're going to answer on the answer sheet. Let's go on to the next one. Solve each of the following. It says hint, write it in standard form. So we get into standard form first, it can help us with graphing, or factoring. So 5x squared, pull this over, we're going to subtract 3x, it becomes negative 6x minus 8 equals 0. We can't take anything out here, so we've got to find our AC. AC is negative 40. Two numbers that add to make negative 6 are going to be negative 10 and positive 4. So we want to write out our 2 sets of parentheses. Now I'll write this to be negative 10 and that to be 4. So if it's going to make 5x and x, the two first positions make 5x squared, so 5x and x. And that's nice because 5 times something makes negative 10 would be 2. And negative 2 times something has to make negative 8. And then 1 times something has to make positive 4. So it has to be positive 4 over here. And then we just do the zero product property, which means we just take the parenthesis and set it equal to 0. And divide out. We move over and divide, we get negative 4/5. And x equals 2. So final answer is negative 4/5 and positive 2. Next one, let's move this 6x squared over. We're going to subtract, so we get 5x squared plus, minus 12x plus 4 equals 0. So our AC is 20. And that would be 10 and 2, both negative, to make positive 20 and the negative 12. So right, you put parenthesis. I'm going to make this one become negative 10 and this become negative 2. I'll get a 5x squared again, so it'll be 5x and x because first positions make this 5x squared. I'm going to make a 4, so it can be 4 and 1, 2 and 2. 5x, negative 10 means this is negative 2. And that would be also negative 2 because this times something makes negative 2, so it has to be negative 2. We get 5x minus 2 equals 0. 5x equals 2. X equals 2/5 and x equals 2 again. So 2/5 and 2. This next one, pull over this x squared, I get 5x squared minus 33x plus 40 equals 0. So AC, this time is 200, much bigger numbers. So numbers that multiply to make 33, that's going to actually be 8 and 25. So you could take 200 and break it down, that would be 2 and 100, and then we've got 4 and 25, and then that's how we found, you can break it down different ways, but we've got to find two numbers that multiply to make 200, but add to make 33. Okay, so we're going to make negative 25 and negative 8, so that's 5x squared, and it would be negative 5. I'm going to put an x here because 5x squared times x, 5x times x makes it 5x squared, and negative 8 there, so 5x minus 8 equals 0, 5x equals 8, x equals 8/5, and x equals 5. So 8/5 and 5. Oops. Alright, part D, 5x squared plus 27x, 0. AC is 50, and the two numbers are going to be 2 and 25 when we add them. So that's going to be 25 here and 2, and that's 5x and x, and that would be x and positive 2. So 5x plus 2, x equals, so equal to 0, equals negative 2 over 5, x equals negative 5. Alright, 4x squared minus 9x plus 5 equals 0. Your AC is 20. Be negative 4 and negative 5 to get to negative 9. So that's negative 4, negative 5. So 4x and negative 1 makes a negative 4. That's going to be an x here because 4x times x makes 4x squared. So we need a negative 5 here. Negative 5 times negative 1 makes positive 5, and then these numbers make the negative 9. So 4x minus 5 equals 0, x equals 5/4, x minus 1 equals 0, x equals 1. Remember, I'm just moving this over to make it 5 and then dividing both sides by 4. Solutions, 5/4 and 1. Next, 4x squared plus 17x minus 42, but add over that 2, add over the 17. AC is 168. So I do a bit of work here. I get 2 and 84, and then 42 and 2 and 21, and then 3 and 7. And actually 7, and what's left over is 2 times 2 is 4. What do we get left with here? 7 and 24. So we need negative 7 positive 24. So let's write it with parentheses, and I have 24 and negative 7. The 24, it could be 4 and it could be 2 and it could be 2 and 2, or 4 and 1, and I have to make 42. So it's easier if I do 4 and 6, because 6 and the 7, because of the 7 that's over here. Oops, I need a negative 7 here. So it's easier if I have the 6 and the 7 to make the 42. So when I solve this, I get 4x equals 7, and one of the solutions is 7/4, and then negative 6. Okay, let's move this over. X squared 0. Now I can actually take out a 3 to make this a smaller problem. X squared plus 10x 25 equals 0. Then my AC is 25. And my two numbers are going to be 5 and 5, which actually means this is a perfect square trinomial, so it's going to be x plus 5 all squared. How do I know this? Can I square out the first term? I can, it's 1. Square out that term, it's 5. 5 times 1 is, or x is 5x, times 2 is 10x, therefore it's a perfect square trinomial. Set it equal to 0, divide both sides by 3. That means I can set it equal to 0 here, and I get the solution is negative 5. Here, I get 25x squared. These cancel out when I move it over, and then I move this over, I get negative 4 equals 0. So there's a couple of ways you can do this. You can go ahead and solve it by moving the 4 over, dividing both sides by 25, and that gives me plus or minus 2 over 5. I square rooted both sides. Square root of 4 is 2, square root of 25 is 5, and I have this. Or I can take this here and write it as 5x minus 2, 5x plus 2 equals 0. And now what I have is a difference of squares. So I can move over the 2 and divide by 5, move over the 2, make it negative 2, divide by 5, and I'll get both plus and minus 2/5. So if I was asked to just factor, this is what I would do without the equal to 0. If I'm asked to solve, I can either do this and set each part equal to 0, or just do this and get the solutions. Either works. Alright, here I'm going to move this over, so I've got 4x squared minus 24x plus 36 equals 0. Our AC is, actually, hold on a second, square root of 4 is 2x, square root of 36 is 6, put a negative in here, 2 times 6 is 12 times 2, so it's a perfect square trinomial. So that means we just do 2x minus 6 equals 0, 2x equals 6, divide both sides, and we get 3. One solution. I could also have taken out 4 and be left with x squared minus 6x plus 9, and that would have given me also 4 times the quantity x minus 3 squared equals 0, and then from there I would have gotten 3 as well. So either of these work. Alright, last page. Okay, so this one we gave you a choice of, in terms of how to solve this. This is up to you how you want to do it. If you want to graph it, go for it. If you want to factor it, square roots, however you want to do it. I'm looking at this and I can see right away I can take out a 2. I've got x squared plus 2x plus 1, and I actually know it's a perfect square trinomial because I can square root this and get x, I can square root that and get 1. Multiply them together and double it gives me 2x squared, and this is just from practice. Could I have moved over this 8 and then factored from there? Absolutely. This is not necessarily the best way to do it. It's just a way what you can recommend. So I'm going to have this, and then when I move it over, I would be left with, x equals negative 1 plus minus 2, and just go ahead and solve. So you get positive 1 and negative 3. Or I could have done it as 2x squared plus 4x minus 6 equals 0, took out a 2, x squared plus 2x minus 3, and had to factor that. I would have had AC is negative 3, so x and x3, 1. I'd need a negative 1 and a positive 3 to get up to a positive 2, and then I would have had x equals 1 and x equals negative 3 is my two solutions to write like this. So there's different ways of doing this. This is what's nice about this. Could have graphed it as well. A bit more work, we'd have to find the vertex. So yes, can do it, don't have to do it. Here, I'm going to divide, there's a couple of things I can do. I can move the 16 over and have 16x squared minus 4. If I move it to this side, equals 0, and then I can do a difference of squares. And I would have 4x minus 2 and 4x plus 2. And that would have given me 4x minus 2 equals 0. 4x equals, this is where you've got to be careful, is 1/2. And that would be negative 1/2. Or I could have started with this here, divided both sides by negative 16, so that gives me 4 over 16, the two negatives make it positive. And then I could simplify that. The x squared is going to be 1 over 4, and then square root it, and that would be 1/2, plus or minus 1/2. From here I could have square rooted from here, and I would have had plus or minus 2 over 4, which goes down to 1/2. So there's different ways, again, of doing this. Neither of these is right, wrong, better, worse. So whatever you're most comfortable with. Some ways there's only one, some of these are only one way to do it. Here, I'm actually going to isolate and try and get this part here on its own. So first things first, I'm going to move that 2 over, and that gives me 16. And then we divide everything by 4. And then I'm left with 2x minus 3 squared equals 4. And from here I can square root both sides, and that gives me 2x minus 3 equals plus or minus 4. 2x equals 3 plus or minus 4. So let's take care of this. Well, actually, let's divide both sides by 2. It's a bit messier. 3 plus or minus 4 over 2. So then I'll do 3 plus 4, so that'll be 7 over 2. So that's one answer. 3 minus 4 is negative 1 over 2, and that's my two solutions. Actually, I just realised I forgot to divide that, square root that, and make it 2. Sorry. That makes that 2. That makes that 2, and that will be 3, that will be 5, and then 3 minus is positive. My bad, sorry. I just forgot to, I square rooted it but didn't write it. Said it and didn't write it. I could have graphed that as well. It would be easier if I'd moved this over, but negative 16 is not an easy one to graph. So, and the very last one, so these are your solutions, so that it would have been x minus 2 would have been the factor, and this would be x plus 5. And then from here it's just distributing, so x squared plus 5x. So x squared plus 3x minus 10. This one here. A bit more to this one. I want to get rid of this 2 first, because when I solved, let's see, I have one here. Okay, when I solved this, the first thing that I did was add over the 2, and then I divided by the 4 last. So that's the first thing I have to get rid of, is that division. And that's the same thing here, so I'm going to multiply. So it becomes 2x equals 3, and then 2x minus 3 would have been the original factor that I would have used. And same thing here, it would be 4x equals negative 1, so 4x plus 1. So your factors are 2x minus 3 and 4x plus 1. And then it's just a case of distributing this out and gathering our like terms. And then last one, again, move this over first, so I'll get 3x equals negative 5, 3x plus 5 equals 0. This one's easy enough, just move it over. So I have 3x plus 5 times x plus 3. Distribute, so 3x squared plus 9x plus 5x plus 15. Put together your like terms. 3x squared plus 14x plus 15. Okay, done.